Okay, so in today's lesson, we're dealing with more equivalent measurements, except, or conversions. This time we're using decimals instead of just whole numbers, but everything else is basically the same. My conversion factor is an important thing to know. I call it the CF. In this first problem here, we're taking kiloliters and we're turning them into liters, so I need to know how many liters fit in a kiloliter, and that answer is 1,000. So my CF is 1,000. Now, ordinarily, I would just say, okay, take my 2.7, we multiply it by my CF, and what we'll do then is we'll build a nice little place value chart here. 1, 2, 3, 4, 5. Here's my 2.7. Here's my decimal, and we're going to, or every digit is going to increase in value by 3 place values. 1, 2, 3. So 2 in the ones place becomes 2 in the ones, tens, hundreds, thousands place. And the 7 in the tenths place moves 3 places to the hundreds place. And here's my answer of 2,700. But lately I've been getting involved in this, and I've been really starting to like this whole number line deal. On the bottom here, we'll deal with our kiloliters. Here I have 0 kiloliters. I have 1 kiloliter. I have 2 kiloliters. And I have this little guy here, so here's my 3. It has a little guy here, maybe this is my little 0.7, adding on. So you can see this visually. On top, I'll do my liters. So if I have 0 kiloliters, that means I have 0 liters. If I have 1 kiloliter, I have to multiply that by 1,000. That gives me 1,000 liters. Over here, 2,000 liters, or 2 times 1,000. And over here, everything's times 1,000. So I have my 0.7 times 1,000, 0.7 times 1,000, which gives me 700. Now, if you needed to work that also, we could do that on the side too. Yes, I'm going to be throwing a lot at you for this particular lesson. Here's my 0.7. Here's my decimal, and in this case, once again, I'm gaining 3 place values. 1, 2, 3. There's my 7. There's my 700. Now I take my 2,000, excuse me, and my 700, and there is my 2,700 liters. Okay? I know it's a lot. I'm showing you all kinds of little diagrams and things, but it's good to see. It's good to know. It's all great stuff. Now things get a little more complicated when we look at a problem like problem B over here. Here we have fluid ounces, and here we have cups. And so let's work this one here. So cups to fluid ounces, my CF is, of course, my most important number, and my conversion factor, and how many ounces, fluid ounces, go into a cup. That would be 8. Okay. And now I can set things up a little bit. I can start my number line if I want to go right to my number line. And since I need cups here, so that's 0 cups. That's 1 cup, 2 cups, 3 cups, 4 cups, and a little extra. Here's my 0.25 cups right there. So 4.25 cups. Now on the top here, let's do, okay, let's put my little C for cups here. I'll put the whole word. On the top here, fluid ounces, 0 fluid ounces. And since we have 8 ounces for every cup, here's my 8 times 8. Everything's times 8. Times 8, times 8, times 8, even my 0.25. So I have a 16 here. I have a 24 here. I have a 32 here. Now here I might have to work this out. On the side, I have my 0.25. Here's my 8. Okay. So my 8 times 5, that gives me 40. My 8 times 2 gives me 16. 17, 18, 19, 20. There's my 20. And since I'm multiplying by 100 here, to get rid of that 0.25 to make it 25 in my head, that means I need to divide it by 100, which means 200 becomes 2, simply 2. So this is a plus 2. So my 32 plus 2 gives me 34. Okay? Or perhaps I can just simply take my 4.25 right from the start, and I can multiply that by my 8. Okay, so 8 times 5 gives me 40. 8 times 2 gives me 16. plus 4 gives me 20. 8 times 4 gives me 32. Plus 2, 34. And once again, this was a times 100. To get rid of that decimal, to make it 425, which means down here I need to divide by 100. So 3,400 becomes 34. There's another way of doing it. Okay? So that's it. That's the deal. All right. Take care. Thanks so much. Bye-bye.